This is Dr. Carroll, and today's video is about different kinds of inheritance, meaning public, protected, or private. Let's back up and do a review about accessibility, where we have the accessibility interface identifier, public, private, and protected. What does that mean? Who can access what? Well, with public, the items, the members in there are accessible to all clients of the class. For private, only the members and the friends of the class can access those members. And protected, we've talked about that several semesters ago. It's only members of the class and also friends of the class and all derived classes. And so that's new with inheritance that we're going to see here. With public inheritance, the public and protected members of the base class are then public and protected members, respectively, in the derived class. So with public inheritance, we can get access to both the public and the protected members of the class. With this type of inheritance, we have an is-a relationship. For example, a student is a person, a cat is a mammal, a square is a rectangle is a shape, notice the hierarchy there, and a binary tree is a tree. It is by far the most common type of inheritance. The syntax for it is we have a class base class, and then we do colon public, and then the name of the parent class. Here's an example. We have a class mammal, and then we're going to use that as the base class and have a derived class cat, which inherits publicly from mammal. And the little ASCII indicates the area there. So a derived class inherits the data members and member functions of the base class, and it can also define new members as well. Additionally, derived classes can revise, change, or overwrite any inherited member functions. A derived class inherits all members of the base class except for the constructor, the destructor, friend functions, and overloaded operators. An important rule to note is that a derived class constructor executes after the base class's constructor executes. And that's so that the derived class can override any initializations that occurred in the base class. Now, that's the constructor. What about the destructor? The derived class destructor executes before the base class's destructor. Let's see an example. Here we have it's a project, it's online. We have a mammal class, which will be our base class, and we have a derived class, which is a dog class. So we have a mammal and we can ask the mammal to speak. And then we can create a dog, and we can say, set the dog's weight. We can print out the dog's weight, and we can have it speak. But furthermore, we can have it print out the breed. Notice we'll see that the breed is not specific to a mammal, but only in a dog. First, let's look at the base class. Here we have mammal, and we have get age, get the height, get the weight. We have the setters, and then we have speak here. Okay, and then notice it's protected and not private data members. And just to illustrate the point, I've put in print statements in the mammals constructor and destructor, and also in the speak. Now, dog here is an example of public inheritance, as you notice is public here. Again, we have a destructor and a constructor and destructor. We have things that are specific to a dog. For example, the breed, print the breed. And notice we are overriding speak here. Okay? So we say, here we print out that the dog's constructor is executing, and that the breed, we're just going to default to a Labrador if nothing is specified for now. Print out that the destructor is executing, and in dog speak, it says bow wow, which is appropriate for a dog. And then notice we also have a print breed command which is specific to the dog class, which did not appear in the mammal class, and it prints out what kind of what the breed is. And that's what we have here. Notice we've been able to reuse a lot of the code because we're inheriting. Let's see it. So first we created a mammal object, and we can see that the constructor is executing here. And we called mammal speak, and that's executing here. And then we instantiated a dog object. Notice that as soon as we did that, the mammals constructor is noted as executing, and then the dog's constructor. The base class's constructor executes first before the derived class constructor. We set the weight, we ask dog to say what it is, we ask what its breed is, and then the object gets destroyed because it's an automatic variable. And the dog's constructor, destructor, is executed first, and then the base class's destructor is executed, and then this is the one for animal here. There's lots of rules for inheritance. Declarations in the derived class can hide the declarations of base class rather than overloading them. For example, we saw that with the dog speak. It did appear in mammal, but it also appeared in dog as well. So a rule with inheritance is that when a base class constructor requires parameters, the derived class constructor must explicitly call the base constructor and pass the necessary parameters. Let's see that. Okay, so this is when the base class's constructor, all we did was change the constructors in this example here. This one's also online. Is it's requiring a parameter. Notice then in the dog, then we have to explicitly call it, okay, or it will be explicitly called if we don't, and we need to pass it what it needs. So mammal's just doing weight, but the breed is specific, so we do that here. In the driver array of something very similar, we instantiate an animal with a weight of 10, and then a dog with a weight of 20, a height of 4, and it's a different breed here. Let's see it execute. Okay, this is the animal. Its constructor is going. Then we have a dog, and notice the mammal's constructor is called, and then the dog's constructor is called, and that's necessary. Play around with it, delete it, and see what kind of errors you get. See how that works out. We can print out the animal's weight, we can ask what a dog says, we can ask what an animal says, and then the destructors again. So we can also have private inheritance, which is a different kind, and that's when the public and protected members of a base class are private members of the derived class. It forms an as-a relationship. For example, a stack can be implemented as a list. And we note that here with the :private list, we're implementing it, and then all of the public and protected members, not the private, but the public and protected members of the list class are then private to the stack class. This is rarely used. Just make it a data member, that's composition, when you can, and only use private inheritance when you have to. That brings us to protected inheritance, where the public and protected members of the base class become protected members in the derived class. So what you could infer from this is that a derived class of a protected derived class has access to the grandparent base class. It forms a has-a relationship. For example, a car has a chassis. It's inherent in it. It has it. This is also seldomly used just to gain access to the protected data members of the base class, or if we're really trying to conserve memory. So in review, a derived class inherits all members of the base class except the constructors. And remember, if the base class constructor requires a parameter, the derived class must have its own constructor, which calls the base class constructor, the destructor, friend functions, and overloaded operators. That's it.